All right, so we're going to have a look at another question from the 2023 HSC Advanced Maths paper. So this is question 32. So this is the last question in the paper. This is quite a complicated question in terms of the actual functions involved. So we're given two curves, y equals e to the power of minus 2x and y equals e to the minus x minus a quarter. We're told they intersect at one point. We're told the coordinates of the point of intersection. We're told not to prove this. Find the area and show that in its exact form, it's a quarter log 2 minus an eighth. So the bigger curve between the y-axis and the point of intersection is y equals e to the minus 2x. So we're going to do this as an integral. The area is going to correspond to the integral between 0 and the x coordinate of the intersection, which is that log 2 of e to the minus 2x minus the lower curve, which will be e to the minus x minus 1/4. And this is all integrated with respect to x. So e to the minus 2x is going to become, this will be minus a half e to the minus 2x minus e to the x will become plus e to the minus x. And then minus a quarter is plus a quarter. That will become plus 1/4 times x. Now we can sort of check this as we're going along. This is going to be evaluated from 0 up to the natural log of 2. At 0, sometimes the whole expression goes to 0. In this case, we have e to the x's, so it won't. So we actually have to evaluate both of these. So we end up with minus 1/2 times e to the minus 2 ln 2 plus e to the minus ln 2 plus 1/4 times ln 2. Now this term is good. We should be happy with this evaluation because we can see the 1/4 ln 2, which comes from the answer in the question. So this is minus the evaluation at 0, which is minus a half e minus 2 times 0 is 0, e to the 0, plus e to the minus 0, which is 0, plus a quarter times 0, which is 0. So we can try and simplify some of this straight away. We get minus 1/2 e to the minus 2 ln 2 plus e to the minus ln 2 plus 1/4 ln 2. Now, e to the 0 is 1, e to the 0 is 1, 0, that's just 0. So we have minus a half plus 1. So this whole thing becomes a half, but it's negative. So this is minus 1/2. So now we just need to simplify these first two expressions. We're using index laws. The first one we can rearrange to be minus a half times e to the ln 2 all to the minus 2. And the second one by index laws can become e to the ln 2 all to the minus 1. And this is plus 1/4 ln 2 minus 1/2. Now e to the ln 2 is actually just 2. So this is minus a half times 2 squared plus e to the ln 2 is also 2 plus 2 to the minus 1 plus 1/4 ln 2 minus a half. So we have 2 squared is 4. 2 to the minus 1 is a half. So we get minus half times 4. That's going to be minus 2 plus 1/2 plus 1/4 ln. Sorry, we've lost a minus here. You have to be very careful. These functions are slightly messy to evaluate. So we should have, this was a minus 2. This is actually a minus 2. So this is going to be minus an eighth. So it will be, instead of being 4, it'll be 1 on 4. So it'll be minus a half times 1 on 4. So that's minus 1/8. And we can sort of check this as we're going along, right? We're sort of scanning to see if the numbers add up or if we've lost or gained a negative. Because there's exponentials and logarithms in this, it's very easy to lose or gain negatives when you're using your index law rules. plus 1/2 plus 1/4 ln2 minus 1/2. Well, plus 1/2 minus 1/2. So this is equal to 1/4 ln2 minus 1/8. And this is what we were trying to show. So this is how this question works. It's worth 3 marks. The marking for this is pretty straightforward. For 1 mark, you have to have some integration expressing how the functions relate to the area or some equivalent merit. For the second mark, you have to have a correct antiderivative. So if you correctly antiderive and start to evaluate, that'll get you the second. For the third mark, you have to have the integral, the correct antiderivative, and then the correct evaluation, and must be left in its exact form. And you should arrange it exactly as the answer is in the question, because that's what they've asked you to do, and you want to follow what they're doing as closely as you can. So this is the answer to question 32A from the 2023 HSC Advanced Maths paper.